morning. I hope all of you are doing well. So let's start now. We're going to start with more, we'll leave a bit the derivative rules for a bit, and then we are going to do some, basically, some kind of word problems. I mean, not too many of them, but we're going to just give an interpretation of the derivative as something, and then move on to some math. Let's see, I have notebooks here. Any of them is math. Nope, looks like a physics notebook. Infrared spectrum. Okay, great. Anyways, and there's a, okay. If you lost your book or your notebook, it's here. Now let's look at the derivatives. Now, let's look at the interpretation of the derivative. So we said that if f is differentiable at a, if what? If the limit as x approaches to a of f of x minus f of a over x minus a exists, right? Now, let us look at the difference f of x minus f of a over x minus a. What is this? What do we call this? Did you ever see the word rate of change? Yeah, this is the rate of change, right? This is delta y over delta x. Have you seen this notation? Yeah. So if y is f of x, this is delta y over delta x, right? Delta x being the difference in x values and delta y being the difference in y values. Of course, it's not very clear. This is not a very clear notation, but this is what we call it, right? This is a rate of change. This is the rate of change of f between f and a. Great. Now, what is the derivative? How can I write the derivative at a with this quotient? What do I take? I have this quotient. What do I take to get the derivative? Yeah? Oh, you're looking at the derivative of rate of change of f prime, right? But if you want to take f of x minus f of a over x minus a, what is f prime of a? What do? You're just taking x to, you take a limit, right? As x goes to a, right? So you're taking the limit as x goes to a. How do I interpret this limit as x goes to a? If you were to give it an interpretation. So this is a rate of change between x and a, right? Here x is different than a, of course, right? Because you don't want the denominator to be 0. But if I take the limit as x goes to a of f of x minus f of a over x minus a. What is that number? This is f prime of a. What is that? What can I say? It's the rate of change, but what can I say about this rate of change? Yeah? Exactly. This is the instantaneous rate of change. Instantaneous. Did I write correctly? Yes, I think so. Instantaneous rate of change of f at x equals a. Okay? What's a graphical interpretation of this rate of change? We gave it, if you remember at the beginning, we gave it a graphical interpretation. What is that? Yes?
It's a tangent line.
f prime of a is a number, the tangent line is a line. So these are two different things. But how do they relate? It's the slope of the tangent line. So we also have seen that f prime of a is the slope of the tangent line. So y is equal to f of x at the point where x equals a, or the point a f of a. Remember this? This is how we defined, so we gave a motivations for the derivative. You guys remember this? We drew, like, we took the parabola y equal x squared, and say I took 2 points. I took a point, say, let's say 1 plus 2, 4 here, let's say. And I have a point here, and as I make this point closer to 2, I get a line that is like this. Do you remember that or not? Yeah? So this is the graphical interpretation of the derivative, and you know, a word interpretation of the derivative is the instantaneous rate of change. Okay? So the bigger f prime of a in absolute value is, the more change f has. You guys agree with this? Yeah. Now if f prime of a is 0, you kind of have a, we will see later, you kind of have, you know, a place where, you know, I mean, I won't talk a lot about this, but we will see later. For example, f prime of a is 0, you have something like that. You know, you may have so for example, take f of x, this is f of x. Okay? Where do you expect the change to be more? Here or on top? On the left, here, at the right hand side, or in the middle? Sorry, the left hand side, yeah, my left hand side, or in the middle? The left hand side, right? Because it's steeper, right? It changes faster. You guys see this? Whereas here, it's almost constant. You see that? Here, f is almost constant. It's not constant, but it's almost constant. You guys see this or not? Yeah. Just draw a picture. I don't know, let's look at here, for example. Well, this is more like a line, but anyways. Yes, drawing things is not a strong point, but I have to get better at this. Luckily I passed calculus 1, so I don't have to draw a lot of things, but I mean, you know, let's draw something here, I don't know. Okay, where do you expect f to change more? On this interval or on this interval? Where is the change the biggest? On the left or on the right? On the center? You guys see this, right? This is clear. Okay, I don't need to have great drawing skills in order for you to see this, right? So here really f prime is almost 0 in that case. Okay? Because f doesn't change a lot. You guys see this? Okay, great. Awesome. Here, given application, do we know physics? Yeah, a bit of physics? Do we love physics? So, if x of t denotes the displacement of, if x of t denotes the position of a particle x, okay, at time t, how do I find the velocity? What is the velocity? It's the rate of change, the instantaneous velocity, the rate of change of displacement divided by the difference in time, right? Change in displacement divided by change in time. Great. Now, if I want the instantaneous velocity, how do I have to take my time interval to be close to 0, right? You guys have seen this? Yes. So if my time interval is close to 0, I'm taking a limit. So I'm taking a limit as the time interval goes to 0 of a difference in position over a difference in time. What is that? That's the instantaneous velocity, right? The Did you guys see this or not?
Yeah.
No?
Yeah.
In physics?
Yeah.
You see derivative in physics?
Yeah.
Oh, okay, that's good. So f x of t denotes the position of a particle, an object, at time t f prime x prime of t is the velocity of this object at time. Okay? Let us do a small example and then we move on. Great. So, I'll do an example from the book. By the way, do you guys start having midterms? Okay. No, in general, like not this course, but then you have to start having midterms. Okay. I mean, I can tell like the classes before it was full, now it's emptier. Okay. Okay, so I'll take this one from the book. Page 149. Exercise 12. The height of a rock is given by h of t. H of t is equal to what? 10t minus, what is the number they picked? I think it's 1.86t squared. Okay? This is the height of the rock. Okay, first question. What is the velocity? So find the velocity of the rock after 1 second. What is the velocity? Find the velocity. Do you guys mind if I change this into a 2? I think it's going to be easier if I change it into 2. Let me double check. So I have 10. Yeah. Sorry about that. I'll just change it into 2 just to make things easier. Okay? Nothing, just to make numbers easier. Okay? Find the velocity of the rock after 1 second. So what do I have to do? What is this velocity? It's h prime of 1, right? You guys see this? What's the derivative of h? This is the velocity. And I'm looking at the velocity at time equal 1. This is h prime of 1. What is h prime of t here? Can you help me? H prime of t is equal to what? It's 10 minus 4t, right? 10 minus 4t, h prime of 1. What is that equal to? It's 10 minus 4. Let's say in meters per second. In meters per second. In meters, sorry. Right, in meters is given, t is measured in seconds. This is very important to put the units. T is measured in seconds. Okay, so 10 minus 4, which is 6 meters per second. Great. Now, at what time does the rock hit the surface? Or the floor, you know? At what time does the rock hit the floor? How do I find this? I said h of t is equal to 0, thank you. So for that we solve h of t is equal to 0. don't know if the numbers make sense actually, but this is just an exercise, okay? We don't have to worry. At what time does the rock hit the floor? I set h of t is equal to 0. Yeah, I think they should make sense. Yeah, they should make sense. What do I have here? h of t is equal to 0, so I have 10t minus 2t squared is equal to 0. This is equivalent to what? I can factor a 2t out, so it's 2t. 5 minus t is equal to 0. So I have t is equal to 0, or t is equal to 5. You know, provided I threw the rock from the floor, you know, like it's the rock has been thrown from the floor. So at t equals 5 seconds, the rock hits the ground again. Okay? Now, what's its velocity when it hits the ground again? What do I have to find? If I ask you for the velocity when it hits the ground again, what should I be looking at? Yeah?
H times 5.
Exactly. The velocity, you know, this may not be a question, but the velocity at t equals 5 is, what is it? It's h prime of what? It's h prime of 5, which is minus 10 meters per second, right? Does it make sense or not? Does it make sense that the velocity is negative in that case? Do you guys see that or not? What is the negative velocity? Does it mean I'm slowing down, or it just means a direction, right? If the height is up, then the velocity, if I'm going up, then the velocity is positive. If I'm going down, then the velocity is negative. It doesn't have to do anything with the, well, I don't say anything, but really this is not a measure how fast you're going. Okay? The sign is how, in what sense, in what direction you're going, okay? It doesn't, yeah, so it makes sense that the velocity is negative. Why? Because you're throwing it, and then it's getting back, okay? You see that? You know, that's, you throw it like that, and it's going back. Yep. Okay, great. Awesome. Done with this. Now, let's look at another notation of the derivative. Really, what we have seen here is that the derivative is the rate of change. Everybody, the derivative is the rate of change, delta y over delta x. Okay? Now, is the rate of change of y with respect to x? This is a notation. It's called the Leibniz notation. When delta x is small, by small, what do I mean? I mean it's going to 0. dy over dx we write, I mean, you know, this gives you the derivative, right? We get a derivative. When delta x is small, we get a derivative of y, right? This is more notation and a motivation for you. We get derivative of y with respect to x. Now we write, let's say if y is equal to f of x, dy divided by dx is equal to f prime of x. Okay? A difference of y divided by a difference of x. Okay? Instead of the delta, you put a d. Now, there are many questions that you're going to ask here. And I think many of the questions will be answered in the next calculus course. Maybe we'll answer some of them now. Not now, but in the coming lectures. And more questions are going to be answered when it comes to this notation in calculus 2. Okay? So dy over dx is just a notation for f prime of x. Okay? So let's give an example. So if y is equal to x squared, what is dy by dx? If y is equal to x squared, dy by dx is equal to what? Everybody? Do you guys see that? You just differentiate x squared, what do you get? 2x. Okay? Let's look at dy by dx is e to the x plus tan x. What is dy by dx? A good review of the derivative you have seen. Or no, let's do it slightly harder. Dy by dx. If y is, let's say, x squared plus e to the x tan x, what is dy by dx? Everybody, what is the sum? What is the operation I'm doing here? The last thing I'm doing is a sum. Agree or not?
Yes.
Everybody, do we agree?
Yes.
How do I differentiate this? How do I differentiate this? What's the first thing? X squared. What's the derivative of x squared? Everybody. 2x. Very good. So I differentiate x squared against 2x. Great. Awesome. Now, e to the x tan x. What is this? It's a product. So what rule do I use? I use the product rule. The derivative of e to the x, so I differentiate the first one, keep the second one fixed, plus keep the first one fixed and differentiate the second one, right?
Yes.
Derivative of e to the x, what is that?
Yes.
E to the x times I keep tangent fixed, plus e to the x I keep fixed this time. What's the derivative of tangent x? Secant squared, okay? Great. Okay, awesome. Now, if y is equal f of x, dy by dx at x equal a denotes, is equal to f prime of a. This is just a notation. Okay, so if I want the particular value, if I want f prime of a, I just write dy by dx at x equal a, and this gives me f prime of a. Let's give an example here. Let's get some trig. Do we do some trig functions? Let's look at let's do it more general. Example. So let f of pi over 3. Who wants to give me a number? Number? Yeah? Yeah? Yes. Yours is 5? Oh, okay, 5. I thought you were raising your hand. Yeah. F of pi over 3. F prime of pi over 3. Another number. Who wants to give me a number? In the back, yeah? 9. Okay, great. Find d by dx of, let's see, cos x f of x at x equals pi over 3. What does that mean? This means I have to differentiate cos x f of x and then plug in x equals pi over 3. Do you guys see this or not? Yeah? So let's differentiate d by dx. What is that? Cos x f of x. Right? This is my y here. You agree? This is my function y. How do I differentiate cos x f of x? Who wants to help? Any volunteer? Any volunteer? Yeah?
We use the product rule.
I use the product rule. Very good. So I differentiate the first term. The derivative of cos. What's the derivative of cos? Minus sin x. Very good. And I keep f of x fixed. minus sine x times f of x, plus, what do I do afterwards? I differentiate f and I keep cosine fixed, right? Yeah, we're good. Cos x f prime of x. What is d by dx of cos x f of x at x equal pi over 3? Well, you just plug in pi over 3. What do you get? You get minus sine pi over 3 times f of pi over 3 plus what? Plus cosine pi over 3 f prime pi over 3, right? Okay? Great. Now I just plug in. Provided I know the values of sine pi over 3 and cosine pi over 3. What is cosine pi over 3? 1/2, right? 60 degrees. Cosine is 1/2. What is sine pi over 3? Is root 3 over 2, right? We know these. So this is minus root 3 over 2. What is f of pi over 3? 5 times 5 plus 1/2 times, what did I say? 9? Is it 9? 9? Yeah, times 9. So what do you get? You get 9 minus 5 root 3. Okay? Are we good here? Are we good? Everything's fine? We do one more like this, or that? Can we do one more? Let's do one more. Let h prime of 2 is equal to 5, h of 2 is equal to 10. Fine. Let's see. What do we want here? D by dx of h of x over x squared at x equal to. Okay. How do I differentiate this? hx over x squared, yeah? 5 and 10. 5, I mean, actually, let's pick 11, okay? 5 and 11, okay? Great. How do I need to differentiate h of x over x squared, and then plug in what number? Everybody, 2, right? How do I differentiate h of x over x squared? I mean, you know, this is just really h of x over x squared prime. How do I differentiate that? Let's differentiate this. Who wants to help? Any volunteer? What rule do I have to use here? Quotient rule. Who wants to help? Yeah? Yeah? Very good. I differentiate the numerator. I keep the denominator fixed. Very good. I differentiate the denominator, h of x, over x to the, why did you say x to the power 4? Over the square root of the denominator. Thank you very much. Over x squared squared, right? I'll just write x to the 4. Okay? Are we good here? Okay. So what do I have to do now? I have to evaluate that x equals 2, right? D by dx of h of x over x squared at x equals 2. What is that? This is just h prime of 2 times 4 minus 4 times h, this is not the problem, times h of 2 divided by 2 to the 4. What is 2 to the 4? 16, right? So 4h prime of 2, what is that equal to? Okay, should I rewrite this? Should I rewrite this? It's not here. way, let me rewrite this. So d by dx on h of x over x squared at x equals to, what is that? This is just h prime of 2 times 4. H prime of 2 times 4 minus 2 times 2 is 4 times h of 2 divided by 16. What do you get? I mean, cancel out the 4's, right? You can cancel out the 4. You get h prime of 2 minus h of 2 over 4, right? What is h prime of 2? It's 11 minus 5. H prime of 2 is 5, sorry. It's 5 minus 11, so it's minus 6 over 4, which is minus 3/2. Okay, are we good? Okay, great. Enough with this stuff. Let us move now to tangent lines. Okay, please don't do these things. I mean, on an exam, these are very good multiple choice questions, right? Very nice, very easy to do. I'm not saying you will have something like that, but it's very nice. They are very nice questions. Great. Now let's look at more at the tangent side. Tangent lines. So now suppose that f is differentiable at a. Suppose f is differentiable at a. Are we fine in the back? Are we good? In the back? Yeah, okay. Suppose f is differentiable at a. And consider the points a f of a on the curve y is equal to f of x. So I have a point here. I have a point on the curve y is equal to f of x. It's almost a line, but oh god. Okay? And I have a point a f of a. So x equals a and y is equal to f of a. Now, what did we say about the slope of the tangent line? The slope of the tangent line to the curve y is equal f of x. What is the slope of the tangent line? What is the slope of the tangent line at a f of a? F prime of a, right? The slope of the tangent line of the tangent line to y equal f of x at the point where x is equal to a. So what is the point where x is equal to a? It's the point a. What is the y value of that point? Everybody, if x is equal to a, what is the y value corresponding to that point on the curve? F of a. So at the point a f of a is f prime of a. Do you agree or not?
Yes.
Now, do I have a point on this line? What is a point on this line? A f of a is a point on this line. We agree?
Yes.
Right? Look at here. A f of a is a point on this line. And I have the slope of this line. Right? Now, if I have the slope and I have a point, what can I determine? I can find an equation of the line. You agree or not?
Yes.
Have we seen this before?
Yes.
Yeah? So if I have the slope, what is an equation of the an equation of the tangent line y equal f of x at the point where x is equal to a, what is that? How do I find the equation of this line? So what do I have? I don't know if you know this equation, but I mean, I guess it comes, anyways, I mean, you know, it's y minus f of a, right? The change of y is equal to f prime of a, the slope, times x minus a. Let me rearrange that. This is just y is equal f prime of a times x minus a plus f of a. Okay? Have you guys seen this?
Yeah.
Okay, if you haven't seen this, this is an equation that you could memorize or not. You could still rewrite it every time. This is the equation of the tangent line to the curve y equal f of x at the point a f of a. Okay, are we good here? Let's give an example. This is just a formula that you can memorize. Find an equation of the tangent line to the curve y is equal to, let's see, let's pick an arc function. Y is equal to x squared plus x at the point where x is equal to 1. How do I do this? So first of all, what is my x squared plus x? So how do I proceed here? Do I have my function f of x? What is f of x here? Let f of x be x squared plus x. What is the equation of this tangent line? An equation of the tangent line. Y equal f of x at the point where x is equal to 1 is equal to what? What's an equation of that? This is y is equal f prime of 1 times x minus 1 so what is that? What is f prime of 1? F prime of x, what is f prime of x equal to? F prime of x, f of x is x squared plus x, f prime of x is 2x plus 1, right? Everybody, yeah?
Yes.
What is f prime of 1? F prime of 1 is what? Is 3, and f of 1 is x squared plus x, so it's 2, right?
Yes.
So f prime of 1 is 3 times x minus 1 plus f of 1 is 2, right? So I mean you can keep, sometimes, depends on what you need to do with it. Sometimes you may keep it this way, or sometimes you may just expand it. So it's 3x minus 3 plus 2, so y is equal to 3x minus 1. Okay, are we good here? Is that clear? Yes?
One of the things you want to find that very last one.
It depends on what you want to do. Okay?
If it's a given equation, you want to change that, or you would find the 58.
Again, it depends on what you want to do. Okay? We will see later. Okay? Yeah.
Is that equation of the line like y equals mx plus b?
Exactly. You can find, so if you have a slope and you have a point, you can say y is equal to mx plus b, right? Set m is equal to f prime of a, right? And then use the fact that a f of a belongs to the line to determine the value of b. Okay? You prefer it this way? I don't know. Yeah? Anyways, everybody has their own choices, but I prefer this one for reasons that will be clear later. Okay? Great. We have 10 more minutes. I mean, now if f is differentiable at a and f prime of a is 0, what can I say about the tangent line? If f prime of a is equal to 0, what can I say about the tangent line? If I have a slope is equal to 0, what can I say about the line? It's horizontal, right? You guys see this? If f prime of a is 0, the tangent line to y equal f of s and the point a f of a is horizontal. Okay, so it looks something like this. Here, for example, the tangent line is horizontal. Now, if I have a line that is not horizontal, okay, say it has slope m, okay, and it's not vertical, okay, so it has a finite slope m. If I have another line that is perpendicular to this line, what can I say about the product of the two slopes? This one is. Have you guys seen this before? Yeah. So if you have two perpendicular lines that none of them is vertical and none of them is horizontal, what is the product of the slopes? Minus 1. Have you seen this? No? No? Have you seen this? No, you haven't. I'm pretty sure. Do we know this or not? Yeah? Let's have a small recap. Suppose y is equal mx plus b and y is equal to m prime x plus b prime are two lines let's say with non-zero slopes, with m different than 0 and prime different than 0. What can I say? These two lines are perpendicular if and only if what? Their slopes, the product of the slopes is -1. Are perpendicular if and only if m prime, the product of the slopes, is equal to -1. Okay? So let's double check. The line y is equal to x plus 1 and y is equal minus half x plus 2. Are they perpendicular or not? What is the slope of the first one? 2. What is the slope of the second one? -1/2. Take the product. 2 times -1/2, what is that? -1. So these two lines are perpendicular. Okay, y is equal to 2x plus 5 and y is equal to 1/2 x plus 4. Are they perpendicular? No. The product of the slope is equal to 1. So they're not perpendicular. Okay? Have you guys seen this before? Who has seen this before? Okay. Well, now you have seen this. Okay? Great. Now let us look at the normal line. We'll have 5 minutes. definition. Let f be differentiable at A with f prime of A non-zero. I mean, maybe we can probably define a normal line, but, or you know what? Let f, well, the normal line is a curve y is equal f of x at the point where x equals a. Let's draw the curve here. This is my point a f of a, and this is my tangent side. So the normal line at x equal a is the line that is perpendicular to the tangent line to y equal f of x at a f of a. So it's the line that is perpendicular to the tangent line at a f of a, and well, it's the line through a f of a, let's say. So I have a line that passes through this point that is perpendicular to this tangent line. And this is the normal line. Okay? This is the normal line. So you have the tangent line to the curve at a f of a, right? And what is the normal line? It's just the line that is perpendicular to this tangent line and passes through the point a f of a. Okay? Is that clear? Yeah. Is that a clear definition, everybody?
Yes.
So you have a tangent line at a point, and then you just draw the perpendicular through the same point to this tangent line. Okay. Now let us try to derive an equation of the tangent line. If f prime of a is non-zero, of the normal line, sorry. If f prime of a is non-zero, the normal line y equal f of x at the point where x equals a. So what is the slope of the tangent line? The slope of the tangent line, what is it? It's f prime of a, right? Now if I have a line that is perpendicular to this tangent line, what is its slope? Its slope is m, that satisfies m times f prime of a is equal to -1. You guys see that? So if m times f prime of a is equal to -1, the slope of this line is -1 over f prime of a. This is why I needed f prime of a to be non-zero, times x minus a plus f of a. Okay, you guys see where this is coming from? You have a tangent line. What is the slope of the tangent line? It's f prime of a. So what is the slope of the normal line? It's -1 over f prime of a, because the product of the two slopes is -1. Now you have the slope is f prime of a, you have the slope is -1 f prime of a, and you have a point on the line which is a f of a, and hence you can get an equation of the normal line. Okay, thank you very much, and have a good weekend.